Okay, in this video, I'm just going to talk about how you're going to do the same thing with using ratios and proportional reasoning to figure out the mass of liquids and also to diagram what the molecules look like. This is going to help us answer our big unit question about why do some of the why do some of the liquids layer on top of other liquids. Okay, so here we have all the different colored liquids in 25 milliliter volume. The volume is the same. When you find the mass, here are the masses. Okay, so we're going to practice using these. But look at the masses. The volume's all the same. Which one has the most molecules to be diagrammed? Which one has the most molecules to be diagrammed? The red, right? That one would have the most amount of molecules in the same amount of volume. According to the data table, which liquid would have the least amount to be diagrammed? The clear, because its mass is the lowest, right? We can compare mass when the volume's the same. So the amount of mass to the volume of matter is its density. The density of matter is a ratio of mass to volume. We can use that ratio to predict the mass of different volumes of the same liquid, right? Just like we did with the density cubes, right? So if the green one is 21.9 grams in 25 milliliters, we know it's 43.8 grams in 50 milliliters. How do we know that? Because we increased it by a factor of 2. We multiplied it by 2. We multiply both. If we double the volume, we double the mass. That's because it's a ratio, that's how it happens. The ratio increased by a factor of 2. That would make 100 milliliters 87.6 grams, because it doubled again. Times 2 times 2, right? Whatever you do in the numerator, you do the denominator. You know that rule in fractions? Same is true for ratios. You're increasing by a factor of 2. Okay? We can keep doing that. Okay? The ratio increased by a factor of 2. We can find out what any volume size of the green is for mass if we know an earlier one by increasing it by a factor of 2. It can also be different factors. It doesn't always have to be 2. Notice, like if I didn't know these, but I knew this one, and I knew 200 milliliters, I could find this one. Why? Because it would increase by a factor of 8, right? I could take 21.9 grams over 25 milliliters, multiply both by 8, and get this. So when you see a data table with missing information, that's what you're going to do. Use the ratios. The idea that if one increases, the other increases to find the missing numbers. Okay, the starting ratio can also be decreased by the same factor, and the answer will be an equivalent ratio. I can go the other way. If I know that the blue has 200 grams at 200 milliliters, I can find out how much it weighs at 25 milliliters. Yes, we already had it in the data chart, but bear with me, right? 200 divided by 8 is 25. But at first I had to do, or 25 times what is 200. If I know this volume, 200, right, I can say what do I need to do to the 200 to get to the 25? What factor do I need to decrease by? I know it's decreased because I'm going down. 200 is more than 25. I'm going down, I'm decreasing. I'm going to divide. Divide by how much? By the same number here. So now I'm going to take that 200 and divide by 8. This is easy. Why? Because the ratio is 1 to 1, right? 25 grams for 25 milliliters. It's 1 gram per milliliter. That means that this is easy, right? But the same idea applies even if I have a harder number. In the yellow liquid, for example, it's 21.8 grams, 25 milliliters. 174.4 grams at 200 milliliters, right? I could get that 21.8 by doing the same thing. I know it's 200 divided by 8 to get to 25. So what is 174.4? I'm not going to do that in my head. I'm not even going to do it on a piece of paper. I'm going to get a calculator. put this one in first. 174 divided by 4 gets me 8. Okay, oh, that was the wrong one. But anyway, that was to figure out it's 8, right? But now it's 21.8. When I do 174 divided by 8, I get 21.8. I did that a little backwards because I already knew the answers. But you can take this and use a calculator in Chromebook or in the drawer, okay, to figure those out. So ratio tables, when you see them, and there's a missing number, you're either going to increase by a factor of something or decrease by a factor of something. Increase is multiply, and decrease is divide. Okay? You're going to practice filling in those ratio tables with measurements using different liquids and measurements. Okay? Like we just talked about, if it's increasing, it's multiplying by a factor. If it's decreasing, it's dividing by a factor. And then you're going to match molecules with the same volume. Which one would have the more molecules? All of that is leading up to, you're not having an exit ticket, you're having a, really kind of like a learning log. You're going to pick 2 of the colors that label. And you can pick 2 of the colors that label. And, sorry, 2 of the colors in the bottle and label them for molecules. What would they look like? The top one and the bottom one. And then you're going to label the volume for 50 milliliters and the appropriate mass. We will have already figured out the data table, so you'll be able to do that. But this is your learning log. There will be an exit ticket practicing ratio tables, but you're going to do this before. You can do it on a slide or on paper. Okay? Good luck. Have fun.